Have you ever stopped to think about how your social media feed actually works? I mean, it feels totally instant, but building one is a classic and pretty tough engineering challenge. Today, we're going to tear it apart and see how to build a feed that's not just fast, but can scale up to handle millions, even billions of users.
Think about it. You pull down to refresh and bam, a whole new feed just appears. It honestly feels like magic, but it's not magic. It's just some really clever system design. And in this explainer, we're going to build that very system right from the ground up. All right, so here's our game plan. First, we'll define the core problem we're trying to solve. Then we'll look at the simple, obvious approach and why it's a total trap. After that, we'll dive into the much faster push strategy, map out the system architecture, and then tackle the infamous celebrity problem. And to wrap it all up, I'll give you a cheat sheet for your next interview. Okay, let's kick things off with section 1, the feed's core challenge. Before we write a single line of code, we have to know exactly what we're building. So, the functional requirements are pretty straightforward, right? Users can post stuff, they can follow other people, and their feed should show the newest things first. Simple. But here's where it gets hard. These two down here, the non-functional requirements, they're the real killers. It has to feel instant, under 200 milliseconds, and it has to work for millions of users without falling over. Every single decision we make from here on out is driven by these two goals, speed and scale. And this leads us to what is, without a doubt, the single most critical insight for this entire design. A social feed is a read-heavy system. Think about it. One person writes a post, but that one post might be read thousands or even millions of times. So the ratio of reads to writes is massively skewed. This tells us exactly where to focus our energy. We have to optimize for lightning-fast reads. That's the key to everything. So how do we get those fast reads? Well, let's start with the first idea that pops into most people's heads. It's called the poll model, or fan-out on read. It seems logical at first, but you'll see pretty quickly why it's a common trap. So here's an easy way to think about it. Imagine to get your feed, your phone has to call up every single person you follow, one by one, and ask, "Hey, have you posted anything new lately?" Then it has to wait for all of them to answer, gather up all the posts, and sort them. Sounds pretty slow, doesn't it? And it is. This model puts all of the work on the read path, meaning when you, the user, ask for your feed, the system has to scramble. It has to go query hundreds of different tables or services, merge all that data, sort it, all while you're just sitting there staring at a loading spinner. The conclusion is obvious. This just won't scale. It's a dead end. Okay, so if pulling all the data when the user asks is way too slow, what's the alternative? This brings us to the real aha moment in feed design. We completely flip the problem on its head. Instead of doing the work when the feed is requested, we do all the hard work up front. This is the push strategy, what we call fan out on write. Let's go back to our little analogy. Instead of you calling all your friends, what if, whenever you did something cool, you just sent out one single group text to everyone? The work is done once, by you, right at the start. Now all your friends have the information instantly. They don't have to do anything at all to get it. That is the core idea of the push model. And here it is, side by side. It's all about when the work happens. The pull model does the work when you refresh, which makes you wait. The push model does the work when the post is first created. This means that by the time you open the app, your feed is already built, pre-computed, and just sitting there waiting for you. For performance, this is an absolute game changer. Okay, so we've got our winning strategy. Fan out on write. Now let's actually get our hands dirty and build out the system piece by piece. We'll follow the life of a single post as it moves through our architecture. So it all starts when a user hits post. The post service writes that post to a database, but, and this is the important part, it doesn't try to do anything else. It just fires off a simple message, like a post-created event, into a message queue. Think of this like a digital conveyor belt, something like Kafka. This is great because it decouples our system. Now, a totally separate fan-out service, which has been listening to that conveyor belt, picks up the message. It looks up all the author's followers, and for each and every one, it pushes the new post's ID into their personal feed list, which we keep in a super fast cache. And the perfect tool for that cache is Redis. Why? Because it's an in-memory database, which means it's ridiculously fast, and it has data structures that are perfect for this job, like lists. So for every single user, we have a list in Redis that represents their feed.
When a new post comes in for them, we use the LP push command, which just means left push, to add the new post ID to the very top of their feed list. Instantly. Then, to stop these lists from getting millions of items long, we use ltrim, to just trim the list, keeping only, say, the most recent 1,000 posts. It's incredibly elegant and efficient.
So what's the big payoff for all this upfront work we just did? Well, when a user finally opens their app to see their feed, the server has to do almost nothing. It runs one single, incredibly simple command, lrange. It just asks Redis, hey, can you give me the first 50 items from this user's pre-made list? That's it. No joins, no complex queries, no waiting. That is the secret to loading a feed in under 200 milliseconds.
But of course, no system design is ever that simple in the real world. Our push design is beautiful for the average user, but it has one massive glaring weakness. Let's talk about the classic edge case that every feed designer has to solve, the celebrity problem.
So what happens when a celebrity, someone with, say, 50 million followers, posts a new photo? Well, with our current design, our poor little fan-out service would suddenly have to do 50 million writes to Redis all at once. This would cause a huge processing storm, a thundering herd problem that could delay feeds for everybody, and maybe even crash our servers. A single post could literally bring our entire system to its knees. So what do? The solution is a really clever hybrid model. We basically say, okay, for the vast majority of our users, let's say anyone with under 10,000 followers, we stick with our super fast push system. But for the celebrities, the ones with huge follower counts, we just do nothing when they post. We don't fan out their posts at all. Instead, when you load your feed, we do two things at once. First, we grab your normal pre-computed feed from Redis, then we do a quick separate check for any new post just from the few celebrities you follow. Finally, we merge those two lists together right at the last second. It's the best of both worlds. We get amazing speed for 99% of posts without the huge write spikes from celebrities. Okay, we have covered a ton of ground, so let's boil all of this down into a simple cheat sheet you can take with you, especially if you're prepping for a system design interview. Here are the 5 absolute key takeaways. Number 1, always start by identifying the system as read-heavy. This shows you understand the core problem. 2, immediately propose the fan-out on write or push model. 3, justify your choice of tools. Explain why you'd use Kafka for decoupling and why Redis is perfect for the cache. 4, show off your technical depth by mentioning specific commands like lpush and ltrim. And finally, number 5, don't forget to address the edge case by proposing the hybrid model for the celebrity problem. If you hit these 5 points, you'll show you know how to design for real-world scale. So we've designed a really solid system that can handle your average user and global superstars. But honestly, the rabbit hole goes way deeper. What about injecting a viral post into millions of feeds? Or how do you handle users in different time zones or on different continents to keep latency low for everyone? Those are the next layers of this really fascinating design challenge.